Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is ethylbenzene, benzene with a CH2CH3 group. Moving on to the next step. UlCl3 is a Lewis acid catalyst used in Friedel-Crafts alkylation. However, the reagent shown going into the first arrow is not explicitly shown in the crop, but UlCl3 is the catalyst. Given the context and that the product is used in the next step, the first step likely involves a Friedel-Crafts acylation with an acyl chloride or similar to give product A, a ketone intermediate, acylation product. Looking at option A, it shows a trithylbenzene with a ketone is equal to O, suggesting A is a propiophenone type or polysubstituted aryl ketone. Moving on to the next step. Second reaction with triethylene glycol and heat, triethylene glycol, H2CH2OCH2CH2OCH2CH2O, at high temperature is a high boiling solvent used for Wolff-Kishner type or Clemmensen type reduction conditions. More specifically, heating a carbonyl compound, ketone, with a diol under acidic or basic conditions can effect reduction. However, triethylene glycol with heat, without hydrazine or KOH, is actually used as a high boiling solvent for thermal reactions. In this context, the combination suggests a Wolff-Kishner reduction variant or simply that the ketone C is equal to O is reduced to CH2, deoxygenation. The ketone CO between two ethyl-bearing carbons gets reduced to CH2, effectively giving a fully alkylated ethylbenzene product. And for the final step, Friedel-Crafts acylation of ethylbenzene would place the acyl group ortho or para to the ethyl group, directing the major product, A, at 80% would be para-substituted or a diethyl-substituted aryl ketone depending on the reagent. Given the final product, B, is 1,3,5-trithylbenzene, option B, the intermediate, A, must be a ketone that upon reduction gives the 1,3,5 pattern. The Friedel-Crafts reaction on ethylbenzene can give a diethyl-substituted benzene ketone. Reduction of the carbonyl, C is equal to OCH2, via heating in triethylene glycol, acting as solvent for a modified Huang-Minlon Wolff-Kishner, yields 1,3,5-trithylbenzene. The 1,3,5 arrangement is thermodynamically favored and consistent with para-selectivity in successive electrophilic substitutions. Options A, still retains the ketone so it is not fully reduced. Option C is 1,2,3-trithylbenzene which would require ortho-ortho substitution, sterically disfavored. Option D shows isopropyl substituents rather than ethyl groups. A, retains is equal to O, so reduction did not occur, eliminated. C, 1,2,3 pattern is sterically unfavorable for electrophilic substitution, eliminated. D, shows branched, isopropyl groups, not ethyl groups, eliminated. B, 1,3,5-trithylbenzene is the correct symmetric product of para-directed Friedel-Crafts followed by carbonyl reduction. Therefore, the correct answer is B. Therefore, the correct answer is option B.